Hello students, welcome to the last topic of functions, that is invertible functions. I've written a question which carries 6 marks, and before I solve this particular question for invertible functions, let me come to a theorem which will support the solution of this particular question. The theorem says a function from x to y is invertible if this sign is for there exist. So a function from x to y is invertible if there exists a function g from y to x. I'll just give you one, like small figures so that you understand. Suppose this is f from x to y. From x to y, this is set x and there is an element x inside. This is a set y, there's an element y inside. And this function f is invertible. Invertible means it's inverse, that means back way is also possible if there exists a function g, the name is g, from y to x, such that GOF is ix. GOF will give us identity element of domain set x, and FOG gives me identity element of range set, that is codomain set. Okay, where G equals to F inverse. This G is nothing but F inverse. Okay, with one example we will understand it very easily. This is very simple. Let us take 1 2 3 as three elements of, instead of x I'm taking 1 2 3, and instead of y in the range set I'm defining a function f of x equals to 2x plus 5. Okay, 2 into 1 plus 5 I get 7. Okay, 2 into 2 4 plus 5 I get how much? 9. Yes, 2 3 is 6 plus 5 11. So fx gives me, when I put 1 I get 7 2 9 3 11. Okay, I am looking for a function which is inverse of f, and when I put 7 I should get 1. So to get the inverse of that f, that is fx, what I write is, in place of fx I write y equals to 2x plus 5. Y equals to 2x plus 5. Make x as a subject. Make x as a subject means, instead of this we can write express it in x. Express it in terms of x. Remember this. This is the step. Express it in terms of x. So this equation, when I express in terms of x, it is y minus 5 by 2, which is x, and x is nothing but, what is x? G of y, I get x, so it is g of y. I need to check whether this g of y is f inverse or not. If I put g of y, what is y as? Y domain set is 7 9 and 11. That means function g has a domain set 7 9 11. If I put 7, what do I get? 7 minus 5, 2 by 2, I get 1. G of 9, I'm getting 9 minus 5, 4 by 2 is 2. And g of 11, obviously 11 minus 5 is 6, 6 by 2 is 3. So I'm getting all the elements. So g is what? G is a special function which behaves as inverse of f. Okay, and moreover, if you want to understand the meaning of inverse in a very simple language, 2 is a number. If I multiply this number with its inverse, that is 1 by 2, what do I get? I get an identity number 1. So we are also looking for, suppose this 2 denotes fx. We are looking for f inverse, so that when we multiply f of x with f inverse, that is why we are writing GOF, I should get identity element as x. and when I do f or g, I should get identity element as y. So this is the case, and I hope you understood that GOF is identity element of x. And one more thing, if you have not understood this part, you can understand this concept in this way also. Last day we were doing composition of functions. So let us find GOF. F is f of x. G of f of x. What is G of f of x? This is gy, okay, and fx is what? Fx is your y. Fx I have taken as 2x plus 5. So I can write g of y. What is g of y? Y minus 5 by 2. It is y means fx minus 5 by 2. Now what is fx? Fx is 2x minus 5. So I can write this as 2x minus 5. 2x minus 5 plus 5. This is plus 5. So 2x plus 5 minus 5 by 2. Cancelled. Answer is x. So GOF is giving me an identity element of domain set. Similarly, if you try FOG, which is y, G is the second set is being mapped to first. So I'm taking y, GO and FOG, sorry, FOG is f of g of y. F of g of y. And what is f of g of y? First of all, think f of x. What is fx? Fx is 2x plus 5. Write this as 2x. In place of x, write gy plus 5. What is gy? Gy is nothing but, gy is y minus 5. 2 into y minus 5 by 2 plus 5. In fact, I got y. So there goes the theorem. The theorem says if a function f is such that it is from x to y and g from y to x, then for every function which is going from x to y, there exists a function g to, if there exists, then there is a function which is from y to x. This function is denoted by g, and g is nothing but it is the inverse of f if the function is invertible. Fine. So let me come back to the question which I have written. The question says, f is such that natural number to real numbers be a function defined by f of x is this. So just write what is f of x. F of x equals to 4x square plus 12x plus 15. Okay. And show that f is such that n to s, where s is a range set, is invertible. Now I need to find an inverse function of this first. So what I have said is express f of x as y, 4x square plus 12x plus 15. Now what you can do is convert this to quadratic equation. Quadratic equation says 4x square plus 12x plus 15 minus y equal to 0. Fine. So I can use Sridhar Acharya formula. X equals to minus b plus minus root over b square. B square is 12 square minus 4ac. 4, a is 4 and c is 15 minus y by 2a. A is 4. Right? 2 4s are 8. Okay. X equals to minus 12 plus minus root over. It is 144 and 16 into 15 to 40, and this is 16y. So I can write 16y because it is positive 240 is negative and this is 144. I think minus 96 by 8. If I take out 4 common, I can write it as, and your x belongs to what? X is a domain set, x belongs to natural numbers. I cannot take both the negatives because natural number, because if I take both the negatives, the ultimate value will be negative. So what I will do is I will neglect the negative sign in between. So I will take only positive value. So x equals to minus 12 if I take out plus 4 common. So it is minus 3 plus root over 16 is been taken out from inside. So it is y minus 6 by 8. 4 1s are 4, 4 2s are 8. So what is x? X is minus 3 plus root over y minus 6 by 2. But in fact, x is taken as g of y. So I got two functions, fx and g of y. Then what I will do is I'll write the definition. From the definition is the same as what I was talking about the theorem. A function is said to be invertible, okay, if FOG gets me an identity function of codomain set and GOF gives me the identity function of domain set. Okay. So what I will do is I'm going to utilize this fx and gy to find FOG and GOF. So FOG of y, that is f of g of y. Fine. So what is f of g of y? F of x. Think of f of x. What is f of x? F of x, 4x square. 4, in place of x I write gy whole square plus 12 gy plus 15. Fine. And what if I replace this gy with the value of root over y minus 6 minus 3 by 2? It is 4 into root over y minus 6 minus 3 by 2 whole square plus 12 root over y minus 6 minus 3 by 2 plus 15. Okay. And this is square. 2 2s are 4. This will get cancelled. A minus b whole square. A square is y minus 6 plus b square is 9 minus 2ab minus 6 root over y minus 6. I hope you can see it till here. Plus 12 to 6. 6 times root over y minus 6. 6 3s are minus 18 plus 15. This will get cancelled. This is 3 and this is minus 3. So altogether this gets cancelled. I get it as y. FOG of y is y. Y means identity element of the codomain set. Similarly, if I can find GOF, okay, here. So let us write FOG we have found here. That is identity element of set y. Let us find GOF of x, that is g of f of x. And what is g of y? G of y is root over y minus 6 minus 3 by 2. Root over, in place of y you write f of x minus 6 minus 3 by 2. What is f of x? This one. Root over f of x is 4x square plus 12x plus 15 minus 6 minus 3 by 2. Have patience, everything will come. See, this will come as 9. So it is 4x square plus 12x plus 9 minus 3 by 2. This resembles something square, isn't it? What is that? 2x plus 3 root over 2x plus 3 whole square minus 3 by 2. So I get it as, if square and root gets cancelled, so 2x plus 3 minus 3 by 2. So 3 gets cancelled. It is x, not 2, it is x. Yes. So GOF of x I am getting as x, that is identity element of the domain set, implies what? F is invertible. Implies, I can write here, final answer, implies F is invertible with F inverse equals to G. What is G? Root over y minus 6 minus 3 by 2. This is the, now you know one more thing, if you write F inverse of x, then in place of y you write x minus 6 minus 3 by 2. If you write G of y, then you have to write y. So this is one way of solving that the function is invertible using composition of functions. I want to utilize this particular time to show you one more method with which you can prove the function is invertible. That was, as I was saying in my previous class, that a function is invertible if it is 1 1 and onto. So we can easily prove 1 1 and onto for a function to prove that it is invertible. Okay, so I don't want to wipe many things. I have to write few things from here only. So yeah, yes, F inverse is there, so not a problem. F of x is given as this much. Okay, so I think my question was, F is such that it is from N to R, and to prove invertible, it is from, F is such that it is from N to S, where S is the range set. Okay, so what am I doing is, I'm going to prove that the function is 1 1 and the function is onto. How do I prove function is 1 1? Let x1 x2 is imported from natural numbers, isn't it? If f of x1 equals to f of x2 means what? F of x1 equals to f of x2 means 4x1 square plus 12x1 plus 15 is equals to 4x2 square plus 12x2 plus 15. 15 cancelled. Okay, followed by 4x1 square, bring this 4x2 square this side, plus 12x1 minus 12x2 equal to 0. So if I take out 4 common and say x1 minus x2 also common, this will give me, if I take out 4 common, this is a square minus b square. What is a square minus b square? It is a plus b and a minus b. So a minus b is outside, a plus b I have kept it inside. Okay, plus 4 is taken out common, 4 3s are 12 equal to 0. So we can say either, okay, either x1 plus x2 plus 3 equal to 0, x1 plus x2 equals to minus 3. Oh my god, x1 plus x2 equals to minus 3, and my x1 x2 belongs to natural numbers, so not possible. So what next? 4x1 implies, that means or we write, okay, 4 times x1 minus x2 equal to 0. 4 is going to 0, x1 minus x2 equal to 0, x1 equals to x2, f is 1 1. Okay, f is 1 1 because we could prove that if two images are same, then their object, that is pre-image, is also same. That is why it is 1 1. Now the function is onto also because it is given in the question itself. When the function is mapped from natural numbers to the range set, your codomain set is equal to range. You can simply write here f is mapped from n to s. Codomain is equal to range. So codomain equals to range. In my definition of my previous video class, you can see codomain equals to range, f is onto. No need to think of any other things. Now the function is bijective because it is 1 1 as well as onto. When a function is bijective, it is invertible. Hence, f is bijective and invertible. Okay, why the function is bijective? Because it is 1 1 and onto. When it is 1 1 and onto, what do we say? That the function is invertible. What is the meaning of invertible? That for this function, there lies a function, this one. Okay, if we make a composition of these two functions, we get an identity function. That is why we say it is invertible. And also find its f inverse. In fact, with this particular function, taking it as y, you have to do that Sridhar Acharya formula and this process to get the inverse of this function, f inverse. Okay, one particular problem, very important, solve in two different ways. I'll catch you in the second video. Thank you.